Hello and welcome to another creative coding video. Today we're going to look at repetition, but use it in a new way to be able to do things that we couldn't do before. So let's dive right in and look at this challenge that we've set ourselves. On the screen you can see a series of circles drawn in a row next to each other. There are 1, 2, 3, 4, 5, 6, 7 circles. Now imagine there were not 7 but 70 or even 700 small circles. If we wanted to code that drew those circles, well, we wouldn't really want to write 70 or 700 circle instructions. That wouldn't be intelligent or fun either. So we need a new way to do that. We've previously looked at the repeat instruction. That instruction allowed us to repeat code many times. If you look back at the video, you'll see that it allowed us to write a function and then call that function a number of times, whether that was 5 times, 10 times, 20 times, 200 times, even 2,000 times. And that was a very powerful thing to be able to do, to be able to write code once and then call it many times. Can that help us here? Let's have a look. Let's give it a go and see if it can. So I'm already logged into Open Processing and I've set up the simple library as usual. There it is. And I've got a blank empty draw function here ready for us to start coding. Now, if I make a new function, let's call it balloon. Let's imagine those circles are balloons. Balloon. And let's say it draws a circle somewhere. I don't know, let's just put some numbers in just to get started. 100, 300, size, let's say 50. Now, how do we use a repeat instruction? Well, we of course use the name of the function we want to call, and then we say call it, I don't know, 10 times. Now if we did this, what would happen? Well, let's try it. Let's run the code. There appears to be one balloon drawn, but that's because every time you run this function, a circle is drawn at 100, 300 every time. Now we don't want to do that. We want the circles to be placed at regular intervals. So the first one is at x is 100, next one is at 200, 300, 400, 500, 600, 700. The diameter of these is actually 100, so I can change that. And they're all 300 down. But if this one is at 100, 300, and this one is at 200, 300, and this one is at 300, 300, and so on, how do I make this work? Seems like an impossible puzzle. Let's make those circles a bit bigger. Now, what's changing? It's always good to solve puzzles by recognizing what stays the same and what's changing. So the size stays the same, the vertical coordinate stays the same, but the horizontal position, the x coordinate, doesn't stay the same. Let's put x in there for now. Now, x has to go 100, 200, 300, 400, 500, 600, 700. How do we... maybe we can pass this function a parameter. Now we've seen that before, where we pass information to a function, and that function can then use that information and act accordingly. Have a look at the previous video if you need a reminder. So briefly, what's happening here is that when this balloon function is called, it expects a parameter, a value, to be passed to it, and it's going to call it x. And then when we draw the circle, it's going to draw the circle at horizontal position x. Now, previously we've used something like 100, 200, 3, so we're passing that parameter like this, and that should work to get a row of circles going. Yeah, we can do that, but we said we might have 70 or 700 circles. We don't want to write these sorts of instructions again and again and again. What if we really did have 700 circles? We don't want to write this code 700 times. So that's not really the right answer, is it? Well, there is an answer, and it's a new way of using the repeat instruction, which we've not seen before. Now, we went through that attempt to solve the puzzle just to highlight the problem, so we know what problem this new way of using repeat can solve. Now, it's not like this, because we know that we'll just call balloon 10 times, and that won't work anyway because balloon is now expecting a parameter. The new way of using repeat allows us to keep a counter with a starting value and an ending value, and a step by which that counter increases. And that counter, called a loop counter, is what's passed to the function that's called. Let's have a look at this. So we have a counter that starts at 100, it ends at 700, and it goes up in steps of 100. Let's repeat what we've just said. A loop counter that starts at 100, ends at 700, and it goes up in steps of 100. Now that loop counter, the repeat instruction maintains that loop counter. It creates it and increases it from the start to the end, and it passes that loop counter to the function that's being repeated. So the first time balloon is called, it's past 100. The next time it's called, 200. The next time it's called, 300, 400, up to 700. Let's see if that works. Yep, that worked. Magic. That's exactly what we wanted. Now, because this is a new idea, let's draw some pictures just to illustrate the new way of using repeat. So we have a repeat instruction, and it has a starting value for a loop counter, an ending value, and a step size, and then the function it calls. Now, in our case, it's called balloon. Now, the start, we said 100. We said the end was 700. Goes up in steps of 100. So this loop counter is 100 to start with, which means the function balloon is called like that. 100 is passed to it. Then it's 200. So we have balloon 200, then 300, then 400, up to 700. So the last call to balloon is 700, which is what we want. We wanted the first circle to be at 100, then 200, then 300, all the way up to 700. Great. So that value that's kept and grown is called a loop counter, and we'll hear that phrase a lot in future. It's a very useful thing, not just because it keeps a count for the purposes of repetition, but we can find really interesting ways of using it inside our code as well. Great. Now let's experiment with this a little bit, just so we can get a better feel for how this repeat instruction works. What if our starting value was not 100, but say 400? Let's see what happens there. Yep, so it's a shorter chain of circles, and the first one starts at 400 across. That makes sense? If the first one was at 600, then we'd have a very short chain and it would be on the right hand side. Let's go back to 100. You can also see the effect of changing the upper end, the end of the loop counter. If we counted just up to 300, that would be 100, 200, 300, and again it's a short chain but very much on the left, with the circle at 100, 200, 300. Let's bring that up to 700. Now this third number is interesting because it's the step size for that loop counter. If we were increasing it by say 50, what do you think would happen? Well, the loop counter would start at 100, and the next value would not be 200, it would be 150, then 200, then 250. So it's going up in smaller jumps, which means balloon is called with 100, 150, 200, 250. It's called more times then, isn't it? Because there are more steps between 100 and 700. Let's see the effect. There you go. Many more circles squished in. And if we change the size of the circles, they would all fit nicely next to each other. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is that 13? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yep, 13. And we can go crazy if we want. We can make it go up in steps of 10. Oh wow, there's lots of those there. And of course we can make them very small as well. They're very small there. Right, so that's the idea. That's the new way of using repeat. And what we've done is we've used a loop counter for our repetition, a starting point and an end point and a step size. And more interestingly, we've used that counter in our function to position the circle. Now we didn't have to do that. We could have just ignored it and just drawn all the circles at one place. But we've used that parameter, that value that's passed, the loop counter. But that's not the only way we can use it. We can use it for other purposes. For example, and remember, it's just a number. We can use it in any way we want. Because this is a number, we could use it to create and mix a colour. We could say, I don't know, it's x over 2 for the red part of the colour mixing. If you're not familiar with mixing colours with red, green, blue, have a look at the previous video. Let's say it's x over 4 for the red, green part, and for the blue part, let's just say it's fixed at 128. Why did I divide it? Why did I say x over 2? Well, red, green, blue values go from 0 to 255. and our x is going all the way up to 700. So if I halve it, it'll only go up to 350, which won't saturate the colours too much. Let's see what the effect is. Let's have a go. Well, that's interesting. That's a really nice colour palette. I love the way that goes from purple through a nice colour, can't think of the name for it, all the way up to some kind of peachy, orangey, yellowy colour. That's really nice. Yeah, I like that. But the important point is we've used the loop counter, which goes from 100 to 700 in steps of 50 now, and we've used that not just to place the circle, but to mix a colour. And remember, every time this function is called, that X is different, which means the fill colour and the circle position are different. Let's try one more use. Let's say the circle size depends on the loop counter as well. Now it goes up to 700, so let's say divide that by 3. Let's see what effect that has. Ooh, that's quite big. Let's make it smaller still. Yeah, that's alright, isn't it? Could we get them even smaller? Yeah, that's nice. I like that. That's nice. So, again, just to repeat the important point, we're setting the circle's position and its size, and we're also setting the fill colour based on this X that's passed to the function. And that X is actually a loop counter that starts at 100 here, goes up to 700 in steps of 50. Fantastic. Now that's a really simple example, nothing too complicated, but I think it quite powerfully illustrates this new way of using repeat, and we wouldn't have been able to do any of that with the repeat that we've already known. And we certainly don't want to write circle commands and fill commands, 700 times or 200 times. Not at all. That's not efficient. Okay, just for fun to finish off, I'm going to go crazy and have lots and lots and lots of tiny circles. So let's say I'm going up in steps of 10, and I'm going to make very small circles, and also I'm going to remove the outline stroke because there's going to be lots of them and the stroke might be getting in the way a little bit. I'm going to be interesting to see what this draws. Let's go. Oh, that is tiny. Maybe I overdid that. That's a nice effect. Lovely. Fantastic. Well done for getting this far. We're now at the stage where we're exploring some more sophisticated ideas. There are lots and lots and lots of creative uses for repetition using a loop counter, and we'll keep seeing that, and it'll become second nature. It's the first time we've seen it today, and I deliberately started with trying to solve a puzzle that you couldn't solve easily without this new form of repeat using a loop counter. So I hope you enjoyed that, and we'll see you again next time. Bye.